In this video, all students will be able to write an equation for a geometric sequence. A geometric sequence is a list of numbers that increases or decreases by the same ratio each time. When something increases or decreases by a ratio, what that looks like is it looks like it's multiplying or dividing by the same number each time. So, an example might be 100, 300, 900, 2,700, etc. In this sequence, I know it's a geometric sequence because the ratio that it's multiplying by is 3. However, it might look like it's dividing. An example would be 100, 50, 25, 12.5, 6.25, ... Now this sequence appears to be dividing. What that means for our ratio is that it is a fraction. So what fraction is it multiplying by so that it looks like it's dividing? It looks like it's dividing by 2's. So what would that be a multiplier of? That would be like multiplying by 1/2. In this case, the ratio is 1/2. The numbers are getting smaller by 1/2 each time. I would like you to do your check for understanding on your paper by putting a check mark next to each sequence that is a geometric sequence. Sorry about that typo. A geometric sequence. Go ahead and pause this video now. You should have put a check mark next to the 3 sequences on the left. In the first correct answer, 1, 3, 9, 27, 81, we see that the ratio is 3. It's multiplying by 3 each time. In the second, we'll see that the ratio is 1/2. Actually, those are very similar examples to the ones I just gave you. So here's the tricky one. The last one that is a correct answer, what is the ratio here? What is it multiplying by each time? If it goes from 5 to -5 to +5 to -5 to +5 to -5, what is it multiplying by? The correct answer is -1. So let's go ahead and jump into example 1. We have another typo. My apologies. N and a sub n. The first term is 2, and we got that by just 2. It gives it to us. The second term is what? 6. So how did we get to that 6? If we started with a 2, that means we must have multiplied by 3. The third term is 18. So if you started by 2, and you know that then you had to multiply by 3 to get 6, how would you get to 18? You'd multiply by 3 again. The fourth term is 54. So that would be 2 times 3 times 3 times 3. We can see a pattern that's developing. The fifth term is 162, which you get from 2 times 3 times 3 times 3 times 3. So what pattern do we see? So we see that it multiplies by 3 and that it always starts with 2. So let's make an equation that matches this. In order to find a sub n, what number would we start with? What number did we always start with? We always started with 2. And then we're going to have to multiply it by what number? We keep multiplying it by 3, but now we need to talk about how many times we need to multiply it. We need to multiply it by, let's see, the first term, there was no multiplication at all. The second term, we multiplied it 1 time. The third term, we had to multiply it by 2 times. The fourth term, we had to multiply it 3 times. And last but not least, the fifth term, we multiplied it by 3 4 times. So as you can see, the number of times you multiply is always one less than the term. So here we multiplied by 1 just one time because it was term 2. We multiplied it by 3 2 times because it was the third term. So similar to yesterday, we are multiplying it n minus 1 times. N minus 1 is an exponent because we're talking about repeated multiplication. So 3 times 3 could be written as 3 squared, right? That would be an exponent. This is our equation for number 1. We did that on the previous one, sorry. So we started with 2 and we kept multiplying by 3, but we didn't multiply by 3 until after the first term, so you have to adjust everything by n minus 1. So what would the 10th term be? If you want to find the 10th term, you're looking for a sub 10, and you're going to plug in 10 in place of n. Which means up here, the exponent is actually 9. I would like you to pause this video, and I would like you to multiply that out. 2 times 3 to the 9th power. Just a reminder, you need to take care of exponents first, and then multiply by that 2 that's out front. A sub 10 should be 39,366. The formula for geometric sequences is as follows. A sub n equals a sub 1, the first term, times whatever ratio to the n minus 1 power. So this is the answer for any term. You take the first number, the first term, and you multiply it by whatever ratio it's going up and down by. And it's always n minus 1 times because we don't need to multiply until after the first term. Let's take a look at number 2. Fill out this chart on your own. So pause this video, fill out this chart on your own, and press play when you're ready to begin. So the patterns that I see is I see that we always start with 90. Then it looks like it's dividing by 3, but we need to think of that in terms of multiplying. So if you're dividing by 3, what are you actually doing? You are multiplying by 1/3. That's going to be our ratio. So we have 90, and then we had to do 90 times 1/3, and then 90 times 1/3 times 1/3, and then 90 times 1/3 times 1/3 times 1/3. So let's go ahead and make our equation. Any number, or any answer, can be found by starting with 90 and multiplying, you can use a dot or parentheses, by our ratio, which is 1/3. But because we don't multiply until after the first term, we adjust it by n minus 1. So this would be useful for a question like, what would the 1000th term in this sequence be? Now, I won't make you do that by hand. You could find it out by plugging it in on Google. And if you do, you would be plugging it in like this. On Google, you can say 90 asterisk. Oops, that's not how it looks. Sorry, let me write it in like it was Google. 1/3. And then you would put up caret. That's an up caret, and then you would put 1,000. Oops, sorry, I ran out of room there. If you go to Google right now and plug that in and press enter, you'll get the answer. Try number 3 on your own. Pause this video and only press play after you think you have the correct equation. The answer to number 3 could be written 2 ways. A sub n equals 20 times 1.5 to the n minus 1 power, or A sub n equals 20 times 3 halves, or 3/2, to the n minus 1 power. Thanks, Honey Bunnies!